Hello students. So let's have a continuation of the previous session. In the last class we have studied about explanation of hydrogen spectrum by Niels Bohr using his postulates and followed by some numericals we solved. Now let us continue that explanation of line spectrum by hydrogen. So here Niels Bohr explained about the transition of electron from high energy level to low energy level by emission and low energy level to high energy by absorption. So using that expression given by Niels Bohr, energy of electron in nth orbit can be expressed as minus RH, Rydberg constant for hydrogen, by n square, that equals to minus 2.18 into 10 power minus 18 by n square joule. So this is the expression for energy of electron in nth orbit for hydrogen like species. Suppose in a particular transition, electron is jumping from a level N2, high level N2 to low level N1, from a high level N2 to a low level N1. Now energy will be released as a result of this. Energy will be released. How do we calculate the energy released? As a difference between energy of N2 and energy of N1. Now energy difference between N2 and N1 can be calculated as, which is given as delta E equals to, let us substitute N2 in this expression, that is minus 2.18 into 10 power minus 18 by N2 square minus of minus 2.18 into 10 power minus 18 by N1 square, that equals to delta E equals to, if you take 2.18 into 10 power minus 18 common, 1 by N1 square minus 1 by N2 square. So this is the expression we can use for the calculation of energy difference. Already we solved a numerical also on this. Now when it comes to the frequency of emitted photon, can be calculated as, we have delta E equal to h nu. So nu is equals to delta E by h, that is, what is delta E expression? 2.18 into 10 power minus 18 by 6.625 into 10 power minus 34 joule second. This is energy in joules. So frequency is nothing but this division will be 2 3s, approximately 2 3s it will be cancelled, 2.23s, right? 1 by 3 means approximately 3.29 into 10 power 15 into 1 by delta E here, 1 by N1 square minus 1 by N2 square will be left, right? 1 by N1 square minus 1 by N2 square second inverse. Second inverse is the unit of frequency. So using this equation, we can calculate the frequency also in a given transition. Similarly, one can calculate wave number also. Wave number of emitted photon. A wave number of emitted photon can also be calculated as nu bar is equals to nu by C. Nu bar equals to nu by C. That equals to nu is 3.29 into 10 power 15 over, what is velocity of light? It is 3 into 10 power 10 centimeters per second into, if it is meters per second, 10 power 8 meters per second, of course, 1 by N1 square minus 1 by N2 square. Okay, this is second inverse. Second inverse is cancelled and this will be 1.09677, this division 3.29 by 3 into 10 power 5 into 1 by N1 square minus 1 by N2 square per centimeter, where this is similar to, you can notice that this equation is similar to the one used by Rydberg, 109677 inverse centimeter into 1 by N1 square minus 1 by N2 square. So in this way, Niels Bohr proved that his theory is in consistence with the previous one. See, wave number calculation, this equation is on par with the one used by Rydberg for the calculation of wave number of spectral lines in hydrogen spectrum. Okay, now this is about explanation of line spectrum of hydrogen. Now let us discuss demerits or drawbacks of Bohr's atomic model. See, Bohr's model had satisfactorily explained better than means by giving a modification for Rutherford's atomic model, but still Bohr's model failed to explain spectra of multi-electron atoms, multi-electron species, maybe atoms or species. For example, Bohr's model satisfactorily explained the spectra of hydrogen, helium plus. Bohr's model satisfactorily explained hydrogen, helium plus, Li2 plus and Be3 plus, etc. They are all satisfactorily explained, but it failed to explain the spectra of multi-electron species. For example, helium it has two multi-electron species, its spectra was not explained. That was the main drawback. Second point is quantization of angular momentum. Quantization of angular momentum. He had given that electron revolves around the nucleus in such an orbit where its angular momentum is an integral multiple of h by 2 pi, but it was not proved by Niels Bohr. He had given a hypothesis. Nextly, it failed to explain, this theory failed to explain fine structure of atom. Fine structure of atom, or also called as fine spectra of atom. Fine structure or fine spectra of atom means we have learned about line spectra, right, where sharp well defined lines can be noticed on dark background. When using powerful, more efficient spectroscopic equipment, when they analyzed each spectral line, they noticed that each spectral line is again formed as a combination of several closely spaced lines. This is called as fine structure or fine spectrum of atom. So, this fine spectrum was also not explained by Niels Bohr. Nextly, this theory failed to explain Zeeman effect. Zeeman effect means that is, it is nothing but splitting of spectral lines. Splitting of spectral lines in magnetic field. Splitting of spectral lines in magnetic field. When a spectral line is passed through magnetic field, it splits into several, it gets dispersed. So, that dispersion, splitting of spectral line in magnetic field, which is called a Zeeman effect, is also not explained. Similarly, this theory was also failed to explain Stark effect. Stark effect means what? It is nothing but splitting of spectral line in electric field. Splitting of spectral line in electric field is called as Stark effect. Splitting of spectral line in magnetic field is called as Zeeman effect. Bohr's theory failed to explain Zeeman effect as well as Stark effect. And like this, there were one by one so many drawbacks were elevated for this theory, like failed to explain bonding, chemical bonding between atoms to form molecules. So, the phenomena of bonding between atoms during the formation of molecules was also not explained by this existing Bohr's theory. So, from this one can understand that there was a requirement that time, there is a huge requirement of a more satisfactory explanation for all these things. So, at that moment two assumptions and two theories led to a big turn in the study of atomic structure. They were dual behavior of matter or dual nature of electron, dual behavior of matter or dual nature of electron, and second one is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. See, among these two, let us discuss with this dual nature of matter. Dual nature of matter. So, it was proposed by de Broglie. It was proposed by whom? De Broglie. De Broglie had given a nice proposal like radiation. See, radiation, a photon has both wave characteristics as well as particle characteristics. It has a photon has energy, but negligible mass. We have studied in the Einstein's generalization of quantum theory. Just like that, a radiation or a photon has both wave characteristics as well as particle characteristics. De Broglie suggested that particles like electrons also should have both wave properties and particle characteristics. So, electrons such particles, De Broglie suggested that electrons such particles traveling with high speed should possess both wave characteristics and particle characteristics. Both wave characteristics and particle characteristics. In this way, De Broglie started thinking of dual nature for matter. So, let us have a small explanation about this. And De Broglie used two illustrations given earlier according to Max Planck. What is Max Planck's equation? Max Planck's equation is E equals to h nu. E corresponds to energy, right? Energy of quanta. E is equals to h nu already given. That is equals to E is equals to hc by lambda. E equals to hc by lambda. We all studied this one, right? Similarly, from Einstein's mass energy relationship, mass energy relation, we have E is equals to mc square. E equals to mc square. See, from these two energy expressions, equating right hand side expressions for these two, from suppose this is 1 and this is 2. From 1 and 2, from expression 1 and 2, we have hc by lambda equals to mc square. So, on cancellation of c, lambda equals to h by mc. Suppose if a particular photon or electron is traveling with velocity, with some other velocity, or instead of velocity of light, lambda equals to h by mv. Okay, in this way, De Broglie had deduced an expression for wavelength called as De Broglie's wavelength. This wavelength is particularly called as De Broglie's wavelength. Yeah, we should call it as. That's a notation actually. What is this wavelength called as? De Broglie's wavelength, which is given as h by mv. We have momentum as, what's the formula for momentum? Is mass into velocity. So, momentum P, momentum symbol is P is equals to mass into velocity. So, by substituting that product of mass and velocity with momentum P, lambda equals to h by P. So, one can say that momentum of a particle, moving particle like electron, is inversely proportional to, momentum of a moving particle is inversely proportional to its wavelength. So, few numericals are possible even on this also. So, this is a numerical from De Broglie's dual nature of matter. What will be the wavelength of a ball of mass 0.1 kg? Mass of an object is given, moving with a velocity of 10 meters per second. Okay. So, whenever a numerical is given, I told you already, first you have to write the given data and what is asked to find out. What we have to find, what will be the wavelength, lambda is asked to calculate. Of a ball of mass of the object is given as 0.1 kg and velocity is at 10 meters per second. So, this is stage 1. See, if it is a board exam, there are 4 areas. What is given, what is asked, that is stage 1. Stage 2 is, means level 2 is relation between the given value and asked value. What is the formula between them? From De Broglie's from de Broglie's equation, de Broglie's wavelength equation, we have lambda equals to h by mv, lambda equals to h by mv. So, this is step 2. Now, step 3 is, see, for every step there is a weightage, the blueprint will be given from the board. So, lambda equals to substitution, step 3 is substitution. We know that the value of Planck's constant 6.625 into 10 power minus 34 joule second over mass of object is 0.1 kg into velocity of object. What is the velocity given? 10 meters per second. Now, here we need to convert something here. See, these conversions better you remember. 1 erg is equals to gram centimeter square second inverse square. This will be very useful actually. And 1 joule equals to kg meter square second inverse square. 1 erg is equal to gram centimeter square second inverse square and 1 joule equals to kg meter square second inverse square. Now, here which conversion is useful for us? Joule. So, let us substitute lambda equals to 6.625 into 10 power minus 34 joule is kg meter square second inverse square into second over this is 0.1 into 10 1 kg meter per second. Kg is cancelled, second inverse square in this one is cancelled, 1 meter is cancelled. So, lambda equals to 6.625 into 10 power minus 34 meters, that is it, 6.64 into 10 power minus 34 meters. So, this is simple numerical, we got the value. Now, let us come to another question. So, this is a small numerical from dual nature of matter. The mass of an electron is 9.1 into 10 power minus 31 kg. If its kinetic energy is something, calculate its lambda. See, before starting with kinetic energy, why we have to start with kinetic energy? Let us discuss. We are asked to find out lambda. Lambda equals to h by mv. H is a constant we are aware of. Mass is given in the question. Velocity we do not know. So, we need to get that velocity. Where from? From this expression. We have kinetic energy equal to half mv square. V square equals to 2 into kinetic energy by m. V is equals to root 2 into kinetic energy by m. On substitution, V is equals to 2 into kinetic energy is 3 into 10 power minus 25 joule over mass of an electron is 9.1 into 10 power minus 31 kg. This is a whole power half. So, V is equals to 6 by 9.1 into 25 on cancellation gives 6, 10 power 6. This joule if you substitute kg meter square second inverse square by kg, this is whole power half. On simplification 6 9s 54. 9654. So, it is 0.066 and whole root of that on simplification we will get it as 812, yes, 812 meters per second, because this is also cancelled, 812 meters per second. This is what velocity, half problem only we did. Now, this velocity must be substituted in de Broglie's wavelength, lambda equals to h by mv. Lambda equals to 6.625 into 10 power minus 34 joule second over m is this one, mass of electron. See, mass of electron is given as 9.1 into 10 power minus 31 kg into velocity we got it as 812 meters per second. Again, on this product 6.625 by 9.1 into 812, this is the product we have to do, into 10 power minus 3. This is kg meter square second inverse square, meter will be cancelled, meter will be left, right. 10 power minus 34 and 10 power this one, and on cancellation and simplification, so 6.625 by 9.1 into 812. So, this product will be approximately 10 10 power minus 3, denominator has 1000, 10 power minus 6, 10 power minus 6 means, so approximately 8967 into 10 power minus 10 meters. 8967 into 10 power minus 10 meters, that is 896.7 into 10 power minus 9 meters, which is nothing but 896.7 nanometer, because we have 10 power minus 9 meters as nanometer, right. So, this is another numerical given on photon and dual nature of electron. Calculate the mass of a photon whose wavelength is 3.6 angstroms. So, whenever wavelength, mass, lambda, mass, velocity, these three terms are related in a question, that is de Broglie equation only. So, now de Broglie equation might have been used. Okay. See, lambda equals to h by mv. We are given with what value? H is Planck's constant, m is mass of photon. We have to find out mass. Lambda and v, two variables are there. So, lambda is given, velocity we need to find. No. So, where is velocity? See, read the question once again. Calculate the mass of a photon. It is a particle of light. So, as it is a photon, for a photon, velocity is equal to that of light. Velocity is equal to that of velocity of light. So, velocity of photon is equals to c, that equals to 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeters per second. Now, let us substitute the values. What we have to find? Mass. M is equals to h by lambda into v. H is 6.625 into 10 power minus 34 joule second over lambda value is given as 3.6 into, we will take it in meters, 10 power minus 10 meters, 1 angstrom. This is for angstrom. Into velocity of light is then 3 into 10 power 8 meters per second. Now, on simplification, it is 10 power minus 2, 10 power minus 32, it is 6.6 something. So, that is kg meter square and second inverse square. So, after all cancellations, so this is 10.8, even that also can be cancelled, it is approximately 11. 6.6 by 11 means 6.1 approximately. Yes, 6.1 will be left. So, 6.1 after calculation 13 into 10 power minus 29 kg. So, go through the calculation part once again. So, these are few numericals from dual nature of matter.